we needed to go fast. Okay, let's start with obviously math workshop. But before we do that, we're even going to look at your test. No, I don't have all of them completely graded, but I have graded like the front page and the back page of most people. I let some people, if you weren't here yesterday, you might need to fix your back, and I'll let you do that at the end of class. Some people on the graphing inequalities forgot to shade. Don't know how that happened. We addressed that yesterday. They forgot to shade. But I still want to look at those two questions anyway to discuss the other mistake that I'm seeing a lot of. And the reason it's concerning me is because you're making it then. I assume you're going to make it this chapter, which is bad. Bad. Okay, so on 17, all you had to do was graph. You just graph it. It's already ready to graph. You graph it. Why on 18 do you have to show work?
Because it's in standard form.
Because it's in standard form. Do we graph straight from standard form? No. Now, maybe your teacher taught you there are tricks so you can. It is possible. So maybe you know some tricks, or we've even discussed in the past how you can tell the x-intercept and the y-intercept, and maybe you did that and connected the dots, and if so, good for you. But more than likely, let's see, 6, 3, 2, 1, 4 at a point. 5, you're on my nerves. I should have just said everyone but 5. That would have been so much easier. Okay. If you didn't rearrange the equation on 18, something major went wrong. What went wrong? This was your test. Something went wrong if you didn't rearrange the equation. What was it?
You not flipping the sign.
You wouldn't have flipped that. You're a good point, Xavier. So you wouldn't have flipped the sign because you ended up dividing by a negative. So Will shaded less than, he shaded below, even though he was supposed to flip the sign and get greater than and shade above. So because you weren't paying attention yet. So whoever you were, if you didn't show any work, not only have you probably graphed the line wrong, but you've also shaded the wrong region. So something that was worth 3 points, at most you're going to get 1 point now, and that's only on if you knew it was dotted because it was just less than. So, wow, you just blew a bunch of points on something that was supposed to be super easy. So we don't want to make that mistake. So let's look at what we were discussing yesterday. For instance, number 3 from yesterday, or number 4. They're both in standard form. We didn't just graph from here. We rearranged them both and then graphed. So our learning target from yesterday said we could solve systems of equations by graphing. If Drea is not rearranging the equation to graph, she's not solving by graphing. Okay. And then there was another problem that I wanted to show you that the reason it's taking me so long is because I made a mistake, because it happens to the best of us. So let me show you what I did and why I did it. So, I'm a creature of habit. You're third period, so bless you, you're always the last one to get graded. I started with first period, and I kept noticing on number 4 that no one had my graph for the piecewise. No one had my graph. Like, out of the entire class, no one had my graph. And first period's pretty good at piecewise. So I was like, something's gone wrong. Something's gone wrong. I've done something wrong. So then I started paying attention, and I realized what I did. So I have stapled attached the real solution. But if you had this, I'm going to give you your point for it. Because normally, we assume the top is what we need to do to the left of the fence. The bottom is what we need to do to the right of the fence. And I, like you, assume that even on this problem. And it normally is true. Because normally, they put the less than on the top and the greater than on the bottom. Every other thing we've done has had the less than on the top and the greater than on the bottom. Every single time. What genius decided on the test is when we would flip it up? I don't know. So, on the test, on the test, instead of the less than being the top line, the less than was the bottom line. So, when I went back and regraded the first period's papers, I noticed a lot of them had this graph, which would be correct. Less than 1 should be to the left of the fence, hence why my blue line is to the left of the fence. Greater than 1 should be to the right of the fence, hence why it is to the right of the fence. But again, I, like you, I'm a creature of habit. I assumed top was left, bottom was right, and so I have either graph. So if you had either one, I was going to give it to you. Now, someone was really, they were very sincere. They said, but since we tried, can you just give us points for trying? And I really can't, because you remember that test, there were only 2 piecewise graphing problems. So I can't throw it out because there were only 2 of them. So, and you know it was a big deal from last chapter, so I can't throw it out, but I've got you 2 options. So if you got either of these 2 options, you get all your points. Okay, are there any questions about the test since I'm already on a rant about it? You do not. I'm so sorry. I had to help with the parade. It was so much fun. Okay. You did. Minnie did. It was so much fun staying out in the hot sun. If you are missing the test, or you've missed a quiz, or you've missed something with your life, please, for the love, get it together and come see me as soon as possible. If you think I'm going to enjoy seeing you only Wednesday, Thursday, and Friday of next week because you realize it's the end of the 9-week then, it's going to hurt my feelings and break my heart. I like my brown hair. I like for it to stay brown. Do not make any more gray hairs come to me by stressing me out like this. If you're one of those people whose grades is suffering because you haven't made up something, one of these assessments, please come see me because I like my hair to stay brown. Okay. Are there any questions about anything before we get going on the math workshop? I should see like 1,000 hands trying to volunteer for that first one. I know that. Someone last period tried to do the same thing. Let's start with Drea. Drea? Yeah. It is 2. So the first one is 2. Second one, you can go, Travis. It is correct. So this one was 2. This one is 9 times what? 9 square root of 3 because it was 81 times 3. That's correct. The square root of 81 is 9, so 9 square root of 3. Third one, Abby Grace.
11 square root of 5.
11 square root of 5 is correct. It was 121 times 5. The square root of 121 is 11, so 11 square root of 5, and your group gets a point. Dre, you added a point, right? And Travis, you added a point, yes. Add a point. You should all be at 1. Brady, number 10. Good grief. 13 square root of 2. It was 169 times 2, which is 13 square roots of 2. Perfect. Your group gets a point. Now we're back on the same loop again. Surprise, table 1 and 6 aren't getting in this. Drea, go ahead for number 11. 5 square root of 6, because it's 25 times 6, and the square root of 25 is 5. Perfect. And then, ooh, yes, new hand. Last one.
Is it 2 square root of 2?
It is. It is 4 times 6. Square root of 4 is 2, so 2 square roots of 6. Perfect. Your group gets a point. Okay, do you see how we flew through those? That makes me super happy. 1, it makes me happy because that means we can move on to our notes today. 2, that means they had their stuff done in advance. That makes me super happy. But most importantly, I'm happy because what's happening next week?
No, it's workshop.
There's a math workshop test. I heard it from Drea. Drea gets the point. She had math workshop words out first. Math workshop test is next Tuesday. You do not get to use your actual math workshops on the math workshop test. So you already know we've done like 1,000 of these. We've done so many. Obviously, some of the problems are going to be on simplifying radicals. Clearly, I know for sure Drea and Travis and Abby Grace and some other, and Brady and others have that down. They're going to get that part right. Obviously, we've done a lot of factoring ones too. That's going to be some of it too. I told you on Monday I'll be more specific about which word problems you need to study. But for now, the factoring and the simplifying radicals we seem to have down. Yes, ma'am. Okay, so that makes me happy. Okay, go to your notes while you're digging. Anyone remember the 4 new vocab terms from yesterday? Yes, Xavier.
Consistent, inconsistent, dependent, and independent.
Yes, and your group gets the point. Consistent, inconsistent, dependent, and independent. Okay. If you were not here yesterday, you missed some good notes. You need to get a friend or you need to check Google Classroom and watch the video. The most important part to me would be this little chart we made to ourselves. So we're starting to do something with systems of equations. It's 2 equations. We're trying to solve. If they cross, the spot where they cross is the solution. If it has one solution, we use the words consistent and independent. If they don't cross and they're parallel, and therefore there's no solution because they don't cross, we say our system is inconsistent. Now, and then the last option is the coolest of them all. Maybe they cross, but at every single point. If they're crossing every single spot, and there's infinitely many, it's consistent since there is an answer, but it's also dependent. And so I wanted to go back over the difference between independent and dependent really fast. Independent is with one solution because that one spot is special. It's unique It's independent. It's its own person. Down here with dependent, with infinitely many, there are so many spots that they share. It's not special. It's not unique. So you're dependent. And that makes sense. So when I think of independent, I think of unique. And that's why I think of the one solution. Okay. Were there any questions about our graphing problems from yesterday? I was nice, and I told you could pack up and you didn't have to do the workbook problems yesterday. Now you have a total of 5. My gosh, you're going to get them done because you don't want to do them over the weekend. So you have a checkpoint tomorrow. You can either bank on the fact that you can get it done during the checkpoint, or you might even have time to get them done at the end of class today. You're that good. Okay. Let's see. If you're good with graphing, then let's go to substitution. So Abby Grace this morning, we were talking about what we're doing. We're doing substitution today, elimination tomorrow. She's like, well, yeah, we already did this in Algebra 1. Exactly. That's why we're not spending a lot of time on it. I assume you've already seen substitution. I assume you've already seen elimination. I'm sorry if this is brand new to you. I'm going to need to see your face 0 period. I've got like 50 bajillion phones. I don't have time to deal with you today, but when you fail this next test, you're going to know why. Because we be flying you. Tomorrow, there's a checkpoint. It has graphing and substitution. So you've got to understand substitution. We're only doing 4 problems today. You might be special and get a 5th. I don't know. Second period was special, first wasn't. Let's see how special you are. Okay, someone who plays a sport of some sort. Can you explain what substitution is? Okay, you can have a point for that, Landon. You take someone out, you put another one in. And that's what we're going to do today. We're going to take out X and put in a substitution for him. So our first problem is actually set up perfectly for substitution. We see X is equal to this. So everywhere in that second equation, it used to be 3x minus 2y equals negative 8. But now, I'm going to substitute out x, and instead of using x, I'm going to use his replacement, negative 5y plus 3. So x doesn't get to play this game anymore. Instead, we're putting in negative 5y plus 3. We're plugging him in for x. He is taking x's spot. Just like if x was the quarterback, we're just putting in a replacement quarterback. It's no big deal. We're still going to play the game. Everybody else is still in. We replaced one guy. X is now this. Okay, I'm going to circle this line. No, it's not the answer. We're not near the answer. But I'm going to circle this line because it is important. I know I'm on the right track because this long line has how many variables in it?
2.
But aren't they the same variable?
Yes.
So it only has y. So we're happy because it's only y's. That's why we're happy. Only y's. We did a good job. If, after you've substituted, you still have x's and y's, you did not substitute well. Yes, from here on out, we're going to solve. Bless first period's hard. I did it fast, and someone said, Miss Copeland, you did that so fast. I understand. I'm so sorry. We already had a test on solving equations 2 chapters ago. You can solve pretty fast. You're that good. Okay, if we distribute, we get negative 15y plus 9 minus 2y equals negative 8. If we combine our like terms, we'll have negative 17y plus 9 equals negative 8. If we subtract 9 from both sides, we'll have negative 17y equals negative 17. And when we divide by negative 17, we end up getting y equals 1. Again, me and Travis are on the same page. I guess that was a little fast. Here's the good news for Caitlin. Math teachers are nice. Since substitution is kind of hard and a big deal, we pick pretty nice points. Like this whole number of 1. If you got 1.25 or 1 3/4, you're probably wrong. In fact, I'm so nice. If there's ever going to be on a quiz or a test a decimal problem with substitution, I'll tell Caitlin in advance. Number 5, you get a decimal, don't freak out. Normally, it's going to be pretty whole numbers. So Jessica's going to know I went wrong if I don't get a pretty whole number. Okay. I circled it like I was somebody. Am I actually done? Why? You do. You have to have an ordered pair. just like yesterday, we're wanting to know where the two lines cross, so we need to know that point. Right now, we only know the y value. We still need to know the x. Okay, here is where Xavier does not have to be my twin. Xavier can plug that y value into either equation. It doesn't matter. Now, I'm lazy, so I'm going to pick the top one because it looks easier. And he already knows it in his head. Yes, dear? It is -2, and because, yes, it is -2. For those of us who like to show a little math, our top equation was x equals -5y plus 3. We just found out that y can be replaced with 1. So instead of y, I'm going to put 1. I end up having -5 plus 3, which is -2. So my solution is the point -2, comma 1. Are there any questions about that? It didn't say we had to practice the vocab, but my gosh, clearly we need to get the vocab down. What 2 vocab words should I list now? What 2 vocab words should I list now? Yep. Just get the point. There is a solution, so it's consistent. That solution is that one unique point, so independent. Number 2 already makes me sad. Now, the truth is, in real life, if I see a problem like number 2, and it looks like they're both in standard form, I'm not going to solve it by graphing. I'm not going to solve it with substitution. I'm going to use elimination. But sadly, you don't always get to pick what you want in life. So if the directions say substitution, which they do, we're going to have to solve with substitution. Which equation should we use to solve for a variable? Which one would be easier if we want to get a variable by itself? The bottom one. You can have a point. So if we want to get the bottom one by itself, does it matter which variable? Yes, dear.
Am I going to give you the x mark?
Yes, please.
Are the rest going to be number 6?
Yes, it is. Go to the next one. Okay, so I don't want Mason to think every single time we always get x by itself, so I'm purposely going to solve for y. And yet y equals -x minus 12 doesn't actually matter. Solve for a variable. Doesn't matter which one. Okay, we have y by itself. It's ready to roll. We're going to go to that top equation. It used to be 2x minus 3y equals 6. Now that we know a value for y, we can substitute out y and substitute in his friend, -x minus 12. Y is equal to this, so we're replacing y with that. And again, if you are truly, truly lost, because it happens to the best of us, I know I'm right when I get to this line. Yeah, it's complicated, but I'm happy with it because it only has x's. So I'm happy because it only has x's. Okay, if I solve from here, I have 2x plus 3x plus 36 equals 6. So 5x, because I combine my like terms, 5x plus 36 equals 6. I subtract 36 from both sides. I get 5x equals -30. So x ends up equaling -6. I agree. Again, I get Miss Compton solve that fast. If you're having trouble solving, just keep in mind, it should be a pretty whole number. Okay, once we get our pretty whole number, we can plug it in pretty much anywhere. So Miss Brister, who's with me first period, she plugged it in here. So she did -6, which is +6, minus 12, and she got -6. I plug it in every past period. I've plugged it in the second one. X plus y equals -12. X is -6, so I have -6 plus y equals -12. So y equals -6. But again, Sarah doesn't have to be my twin. Once she gets a value for x, it doesn't matter which equation she plugs it into. She's going to get the same value for y as me if we've both done our math correctly. Okay, and I'm running out of room, so I gotta write my answer. It's -6, -6. What vocab terms should I put? And yes, consistent and independent. I heard it from 4 and 5 at a point. Xavier. Sarah. Yes, Sarah. Okay, you are very, very, very smart. And I am doing these fast, but you are very, very, very smart. We've done 2 problems that were consistent and independent. Do you assume that we need to practice some other kinds of problems? So I assume the next one's either going to be a no solution, which is what vocab term? No solution. Inconsistent. Who said that? Was it you? I thought so. Get the point. And then, what if we got infinitely many? What would the answer be then?
Dependent.
And? It would be dependent and consistent, yes. So, we're assuming one of those are about to happen. Let's go to number 3. Let's go to number 3. I get that Miss Compton is annoying because I get that I am good at math. I'm not even going to lie to you. It comes to me naturally. That's why I'm a math teacher. I get that. I'm not trying to be a smarty pants, but I already know the answer and I haven't even solved the problem. Does anyone else know the answer? Consistent and dependent. You're saying it's going to be infinitely many. Why? Oh my gosh, she's good. Okay, so you have a point for that. We discussed infinitely many. They're the same line, so they're multiples of each other. So you can write this at the top, and if you understand, great. If not, we're still going to go through all the steps. So this is extra. DJ may or may not want this. I bet he will. So this is extra. He doesn't have to have it, but it might help. So that that bottom equation was negative 3y minus x equals negative 6. What can I multiply it by so that instead of a negative 3 in front, it was a 9 in front? If I wanted to multiply it by some number, what number should I use so it would have so my next step would say 9y? So if I multiplied by negative 3, I would have to multiply everybody by negative 3. I would have 9y plus 3x equals positive 18. What does that remind you of? It reminds you of that top line. Don't they match now? Meaning one really is a multiple of the other. If Lyric gets that, and Lyric can show me that on her paper, I don't care what the, on my bad words, directions say. She doesn't have to solve by graphing. She doesn't have to solve by substitution. She doesn't have to solve by elimination. Clearly, she understands the solution. She already knows what it's going to be. She can stop, put these words, and I'm going to give her all her points. But if Lyric doesn't see that, she doesn't understand one is a multiple of the other, then maybe she doesn't need to put this at all. Maybe she needs to actually solve. So if we're going to actually solve a substitution, which equation should I solve for one variable with? The bottom one. Which variable should I solve for? X. X is already the kind of number in front of it. It's going to be easiest to solve for X. So it used to be negative 3y minus x equals negative 6. Got the hiccups. If we add 3y to both sides, we'll have negative x equals 3y minus 6. If we divide by negative 1, we'll have x equals negative 3y plus 6. So we did it. We got a variable by itself. We can now take what we got and substitute it into that top equation. Yes, dear.
Okay, never mind. I was about to ask what happened to the negative by the 3y.
Oh, I divided my negative one in my head. Okay, so our equation used to be 9y plus 3x equals 18. But you and I just found out x can be replaced with negative 3y plus 6. So 9y plus 3, but instead of using x, I'm replacing him with negative 3x plus 6. I need to draw a line or something. They're getting awfully close together. It should be. I got in a hurry because my stuff was so close together. Bless you. It was Layden and Jessica, so both had a point. Thank you.
Wait.
Okay, so it used to be, and my work is so close together on this one, that's my bad. So we solved for x, we got this. Everywhere we had x, we now replace it with that. It's negative 3y plus 6. And again, I'm happy here, now that Jessica and Landon have corrected me, I'm happy here because I know I've done substitution correctly, because my equation now has only y's. Okay, something fishy now happens. Has anyone gone any further and seen the fishy something? What happens? 9y minus 9y. So when we distribute, we get 9y minus 9y plus 18 equals 18. What's 9y minus 9y? 0. So I just have 18 equal 18. Is that a true statement?
Yes.
Does 18 equal 18? That's how I knew from here, since everybody died, and we're just left with a true statement, it is infinitely many. Infinitely many. Okay, so what we assume is going to happen, so infinitely many, the variables all die, we end up with a true statement, like 18 equals 18. With a no solution problem, the variables again die, but we end up with an untrue statement, like 0 equal 18, something that's completely crazy. So here's where Miss Compton goes rogue. This next one I thought was going to be a no solution, and we did it last period, and it's not. It has a solution. Terribly annoying. Wouldn't you like to work a no solution one? Wouldn't you? I would too. So let's work a no solution one. We got some room up at the top, right? Yes. In number 4, the answer is, will you tell me?
A is negative 4.
Okay, so I'll make a deal with you. Yes, dear.
These are for 5th period.
Perfect, thanks. You're welcome. Okay, I'll make a deal with you. We'll skip number 4 because it's another normal one, except it has A's and B's instead of X's and Y's, but you're kind of smart. This one is the A, this is the B. We go in alphabetical order if they dare to use other variables besides X and Y. It's not that hard. I think you can handle it. We'd solve for the top one. I can do it. I have it worked out if you want to see it. But instead, I think it would be more fun to work a no solution and see what it looks like. So here are the 2 equations we're going to use. Yes, don't make fun of me because one of them is really easy. Okay, the top one is y equals x plus 4. The bottom one is negative 2x plus 2y equals negative 10. So we're going to work one extra problem instead. Which equation should I use with substitution? It is already solved for you. Y equals. It's already done. So everywhere in that second equation that I see a y, I'm going to replace it with x plus 4. So it used to be negative 2x plus 2y equals negative 10. But I know y is really x plus 4. So I'm going to have negative 2x plus 2. And then y is really x plus 4. Say it again, Travis. Yes. Okay, are there any questions about this step? And then our worst nightmare happens again. When we distribute, we have negative 2x plus 2x plus 8 equals negative 10. Oh crap, the variables cancel out again. Negative 2x, positive 2x, still the variables that.
Yes.
So we end up with what?
8 equals negative 10.
Does 8 equal negative 10? No. Is that a true statement? No, and since that's complete crap, that's why it's no solution.
What are the inconsistent?
And that's the vocab term we need to throw in, and your group gets 2 points for that. Inconsistent. Woo! Yeah, it's good she's carrying the weight. So, again, if you end up with the variables canceling out, it's either going to be infinitely many or no solution. You just have to figure out if it ends up being a legit statement, like our last one was 18 equals 18, that was legit, or does it end up being something crappy like this, no solution. Brady, I would ask you what you want.
Miss Compton,
Yes, ma'am.
did Rebecca Doyle, was she in second period today?
No, ma'am.
Okay, thank you.
That's my bad. Okay, that was.
Another way to solve it is dividing dividing 1 by 2, and since the y-intercepts are different, slope is the same.
Yes. Yes. Okay, so Brady is a genius. I don't know how he knew what I did. So the other day we had a problem. Here, I'll show you. Did we not just have the problem yesterday, y equals x plus 4 and y equals x plus 5? So all I did was I left one of them the same. I multiplied the other one by 2 and rearranged it. And Brady caught on to that. He's like, if you had just rearranged it back, wouldn't you have realized they have different intercepts? Yes, you would have. And then you wouldn't have had to do what we just did. So again, if you can, there are exceptions to every rule. If you can figure out how to show me no solution and infinitely many without actually using substitution or graphing, I'm going to give it to you because clearly you're showing me you understand the concept. But if you have no idea what you're doing and it says substitution, by golly, you better use substitution. And especially if it has a legit solution, by golly, you better use substitution. Okay, any questions? Will you have these workbook problems that you ought to get done? That would be wise of you to go ahead and get those done. I don't want to see it until you have both done. No offense, it's only 5 problems.